This is the 15th video of the series Business Forecasting, and in this video we are discussing Box-Jenkins ARIMA method. Now this method or this topic is little bit different and maybe initially difficult to grasp compared to the other time series analysis. So I have planned this topic into three distinct parts. So in part 1, that is in today's video, I will discuss only the introduction of Box-Jenkins method. In part 2, we will see the process of implementation, that means the methodology, and then in part 3 we will apply that methodology for a particular set of data. So this is the plan. So let us start the introduction part. So as we are discussing Box-Jenkins method, it is a kind of paradigm shift compared to the process we have learned so far in case of time series analysis. So in time series analysis, we have seen that any data, any kind of data, time series data can be divided into 4 parts, or the data can be segregated into 4 type of parts. So one is seasonality, then trend, cyclicality and irregular component. And depending on the nature of the interaction between these components, there can be an additive model and also a multiplicative model. In case of additive model, these components are added together, and in case of multiplicative model, these components are multiplied to get the final forecast. Now, as I was talking, Box-Jenkins method is a complete paradigm shift compared to this process. So how is it so? Before discussing that, let us listen to these 3 songs in order to understand this very well.
ओ शाम कुछ अजीब थी, ये शाम भी अजीब है, वो कल भी पास पास थी, वो आज भी करीब है।
सलामे इश्क मेरी जान जरा कबूल कर लो, सलामे इश्क मेरी जान जरा कबूल कर लो, तुम हमसे प्यार करने की जरा सी भूल कर लो, मेरा दिल बेचैन है हम सफर के लिए।
क्लांति আমার ক্ষমা করো প্রভু, পথে যদি পিছিয়ে পিছিয়ে পড়ি কবু, ক্লান্তি আমার ক্ষমা করো প্রভু।
So did you hear these 3 songs? They are really different from each other as we talk about mood, genre, or even in terms of the tune itself, aren't they? But believe it or not, they all belong to a same family. And in terms of Indian classical song, this family is known as raga, Yaman raga. And this Yaman raga is a particular framework that apply to all these 3 songs, even though they seem so different from each other. So any naive person cannot catch this similarity, but ask any Indian classical music expert, he or she will definitely catch that all these 3 songs are based on Yaman raga. So likewise in Box-Jenkins method also, our data, any kind of data that is given to us, can be attributed to a particular family of data. So there can be various families, not just 3 that I have shown here. There can be various families. We believe in Box-Jenkins method that any data can be assigned to or attributed to a particular family. So apparently if you see that data, it may not be really visible that this data is from this family, but upon analysis we can find that it belongs to that family. So basically this type of analysis, seasonality, trend, cyclicality, irregular variation, this type of analysis is not needed in case of Box-Jenkins method. Once we attribute a data in a particular family, then using that family we will forecast the unknown portion of the data, that means the future data. So then what is the method that we apply here? So see, first of all, the first step is postulating the general class of model. So we are given a particular set of data, then we will see how which kind of general class of models that can be used for this type of data. Then we will use some kind of filters to see the model that can be tentatively entertained for this particular data. So we have a set of models, general class of models, not all kinds of models, some of them can be applicable to this data, and we will filter out those portions only. Then using some analysis, those analysis that we will learn after some time, we will find some parameters from that analysis, and after checking those parameters we will check the adequacy of the model, that means whether that model is adequate for this data or not. If yes, then that model will be used to forecast, and if not, then we will again see which other models can be used or which other families of data that can be used. So seemingly this is a little bit simpler as compared to the time series analysis, because in time series analysis you have to forecast the trend, then seasonality, then maybe cyclicality, and then you need to add them or multiply them to get the final forecast. Here those kind of circus is not there. In this case, the main beauty or main judgmental process lies with how you fit your data to a particular class of model. If you do that correctly or perfectly, then the rest of the process is very easy. You just forecast using that particular set of model. Okay. Now once this is done, now let us discuss what kind of models are available to us. So the basic classes. The first class is called the auto-regressive models. So before understanding this, let us understand this particular table. It is a very simple table, just period numbers are written here. Then y1, y2, y3 are the actual data, and f1, f2, f3 are the forecasts correspondingly. And here error, I have written epsilon for error. So epsilon 1 is a1 minus f1, that is actual minus forecast. Epsilon 2 is a2 minus f2, that means actual minus forecast again. That means epsilon 1 to 3 are the errors. So very simple, period numbers are written, actual values are written, forecast is written, and the errors are calculated. So, and this can run up to anything like 4 or 5 also. This is just a sample data, just to give you an introduction. Now what is an auto-regressive model? Auto-regressive model will not depend on forecast or not depend on error. It is only concerned with the actual data. That means the actual forecast of period t, that will depend on actual value of t minus 1, actual value of t minus 2, and actual value of t minus p period. And there are these phi 1, phi 2, phi p, these are the coefficient, like same as multiple regression, and this is a constant, and this is the error of the model. So this is nothing but a multiple regression model. Multiple regression model. Only thing is, what are the independent variables? The independent variables are the y values itself, but the lagged y value. That means if you are forecasting for period t, then we will use t minus 1, t minus 2, t minus 3 up to t minus p period, and this is called ARP model. So see, there is an argument p here. P means the number of period up to which this yt minus 1, yt minus 2 values are taken to develop this multiple regression model. And which p we will choose, that we will see, that depends on how the data is matching with which kind of like for example there can be AR1 model or AR2 model, like that. So we will see, we will feed the our data with suppose AR1 and AR2 and check which one is adequate with our data. So based on that we will select either p is equal to 1 or 2. So likewise we will select a autoregressive model. Now this is the first kind of model. What is the second kind of model? Second kind of model is your moving average models. Now please don't confuse this moving average which with our earlier analysis of time series moving average process. This is entirely different. And in this case we will use the error terms. The forecast is defined like this. The forecast of period t is equal to a constant plus the error of period t minus omega 1 error of period t minus 1, omega 2 error of period t minus 2, and this is up to period q. So this is called as MAQ model. So the argument is q, that means which order you will choose. That means it can be again MA1, MA2 and so on. So that means q can be 1, 2 or anything. So based on the adequacy test which we will learn afterwards, don't worry about this right now, we will fit our data and see which model, that means MA1 or MA2 or whatever, will fit best for our model. But this is the general equation for the MA models, moving average models. And again I repeat here that this moving average has got nothing to do with the moving average process that we learned in our time series analysis. Okay, so this was the second class. What is the third class of model? That is the combination of the two. That means AR-MA. We have learnt AR, then MA, then this is the combination of AR and MA, also called as ARMA or ARMA. And simply it is the sum of these two models. So this was the AR and this is the MA, ARP and MAQ. So just a summation of that will give you ARMA model as it is written here, and this is called ARMA PQ model. So two arguments are there, P and Q. So therefore it can be like ARMA 1 0 or 0 1 or 1 1 1 2 and so on, 2 1 2 2, like that. So again we have to see which one is the best fit for our model using adequacy test. But remember these three types of models are possible, that is AR model, MA model and ARMA model. And for AR we will use ARP MA, for MA we will use MAQ and ARMA PQ. But you see this ARP, MAQ and ARMA PQ, all these three models will work only with stationary data. So what is the stationary data? I have discussed these things previous videos. Stationary data is like this. There is no trend. This is a stationary data, non-trending data. And what is not stationary? Suppose there is a trend like this or maybe like this. So trending data or non-stationary data. So what I'm trying to say is this ARP, MAQ, ARMA, PQ, these three types of models are only applicable for stationary data. But then what we will do if we are given with the non-stationary data? Most of the time we will have a trending data, either uptrend or downtrend. So then what to do? So for that we have another process of using auto-regressive integrated moving average model. So when we will say integrated, we will insert an I in ARMA and we'll make it ARIMA. This is called ARIMA. And then in addition to having P and Q as arguments for ARIMA, we now have another argument called D, and this D is known as differentiation. What is the differentiation? Differentiation. So for example, if you have period 1, 2, 3, 4, 5, 6 and the actual values are given here y1, y2, y3, y4, y5, y6 and so on, then you plot that, for example period here and y here, and you are finding that there is a trend. So these values are increasing as we increase the period number. So now we take the difference of what? For example, from y1 from y2, then y2 from y3. So this is y2 minus y1, this is y3 minus y2, this is y4 minus y3. So this is called d2, maybe d2, d3, d4. These are the differentiated values. So now if you plot the differentiated values, that means the d, then you may find that this is a stationary series. So actual series was trending series. Now we have taken the difference, and that difference has given us a stationary series. Sometimes it may be also possible that the first difference of order 1, that will give you again a trending data. Then you will take the second difference, so differentiation of order 2 to make it stationary. So don't worry if these things are complicated to you at this point of time. We will discuss this in detail when we will solve the problem. So in today's video I am just giving you the introduction so that you are familiar with this. Otherwise, if I want to cover all these things in one video, that will be a too long video, so it will be difficult to capture the engagement. So that's it about ARIMA introduction, and this is the end of the part 1 video. In part 2 we will see the model building method. That means how to build a model. We will see the methodology only, not solving any problem. So we will only see the step-by-step methodology, and in the third video, that is part 3, we will actually implement that methodology with an actual data. Maybe we will try more than one data, because in one data we will see either AR1 or MA2, maybe whatever, or then you can only understand how to implement AR1 or maybe ARMA1, but but we want to see that how to implement any data, like it may be a MA model also. Or so the point is I will try to select more than one data, and so that cover more than 2 models. So that's it for part 1, and let us meet together in part 2 of this topic, and until then, thank you so much. Hope you have understood the contents of this video. Thanks again for watching.